Okay, welcome to the notes for September 24th in geometry. Today we're going to finish off the last lesson in the unit. Remember, on Wednesday we have our test over this unit, and on Thursday we have the retest for some of you on Unit 1. Today's topic is slope of parallel and perpendicular lines. And our essential understanding for the day is that we can determine whether two lines are parallel or perpendicular by comparing their slopes. So in your notes, make sure you put that in there, and we have key concepts about slopes of parallel lines. First off, into your notes, in the appropriate place there, you should see to write if two non-vertical lines are parallel, then their slopes are equal. Next, if the slope of two distinct non-vertical lines are equal, then the lines are parallel. So in the first one, we're starting out with parallel lines. Then we're saying their slopes have to be equal. And in the second statement here, we're saying if we have two slopes that are equal, then the lines have to be parallel. And then thirdly, it's saying if we have any two vertical lines or any two horizontal lines, then they're going to be parallel as well. You may need to pause here to copy the rest of this. Okay, are these lines parallel? So we have line 1 and line 2. We have a couple points on each line. So for line 1, we can find its slope by doing change in y over change in x. So in line 1, the y values are 5 and negative 4. So we can write negative 4 minus 5. Take the second y minus the first y. And then our x's, it would be 2 minus negative 1. So we have negative 9 over 3. This slope is negative 3. For line 2, to find its slope, we use delta y over delta x, change in y over change in x. The y values are 3 and negative 4. So we'll take negative 4 minus 3. And for our x's, we'll take negative 1 minus negative 3. That gives us negative 7 over positive 2. In this case, their slopes are not equal. So that means the lines are not parallel. Simple as that. To be parallel, they both had to have the same slope. They both had to be negative 3, or they both had to be negative 7 halves. So if you have some points or coordinates, it's easy for you to tell. Now in terms of writing equations, here we have a line, y equals negative 3x minus 5, and we want to write the equation for another line that contains this point, negative 1, 8. And it needs to be parallel. So our second line needs to be parallel, so its slope has to equal this slope. And the slope here is negative 3. So our line has to have a slope of negative 3. And it has to go to the point negative 1, 8. We use y equals mx plus b. We know this is x and this is y. So 8 equals negative 3 times negative 1 plus the b. 8 equals 3 plus b. Subtract 3, b is 5. And so our equation would be y equals, the slope is negative 3 times x plus the b value of 5. And that would be the equation of the line that is parallel to the given one and passes to the point negative 1, 8. As for perpendicular lines, again, if two lines are perpendicular, then the product of their slopes is negative 1. So I have to multiply the slopes together. If they make negative 1, they're perpendicular. The second statement is the converse of the first one, just turned around. If the product turns out to be negative 1, then you know the two lines have to be perpendicular. And in this third one, what does it mean to have a product of negative 1? To have a product of negative 1, the slopes of the line must be negative reciprocals. And some examples of what we mean like negative reciprocals. 2/3 and negative 3 over 2. 5 over 7 and negative 7 over 5. 3 over 1, negative 1 over 3. Negative 2 over 7, positive 7 over 2. So notice each of the fractions was flipped over and changed to the opposite sign of the original one. So if your first slope is positive, your other one has to be negative. If your first one was negative, your second one has to be positive, and the reciprocal part means we flip over the fraction. And this way, we're going to multiply here. We're going to get negative 6 over 6, which is negative 1. We're going to multiply and get negative 35 over 35, which is negative 1. Or negative 14 over 14, which is negative 1. So that's why we have to flip the fraction over and take the opposite of it. So are these two lines perpendicular? Just like our parallel, let's find the slopes of the two lines. So for line 1, here the y value is 2, here it is negative 4. Remember, slope is delta y over delta x. Negative 4 minus 2. My x's are 0 and negative 4, so 0 minus negative 4. Let me write that better, 0 minus negative 4. So negative 4 minus 2 is negative 6. 0 minus 4 is, minus negative 4 is 4. And this simplifies down to negative 3 over 2. Line 2. Slope again. Change in y over change in x. The y values are 3 and negative 3. So we have negative 3 minus 3. And the y values are 4 and negative 5. So negative 5 minus 4. So this gives us negative 6 over negative 9. A negative divided by a negative is a positive, so we have 2 over 3 when we simplify it. Now notice negative 3 over 2 and 2 over 3 are negative reciprocals. One is flipped and the sign is opposite. And if we multiply them, we get negative 6 over positive 6, so we get negative 1. So line 1 is indeed perpendicular to line 2. What is an equation of the line perpendicular to y equals 1/5 x plus 2? And that line has to contain this point. Well, in the line that's given to us, the slope of that line is 1/5. So for our perpendicular line, the slope has to equal negative 5 over 1, or just simply negative 5. Our point we have to go through is 15, negative 4. So we're going to use y equals mx plus b. We have the m. Here's x. Here's y. So negative 4 equals negative 5 times 15 plus b. Negative 4 equals negative 75 plus b. Add 75 to both sides, we find that b is equal to 71. And so our equation is y equals, our slope is negative 5, x plus our b value is 71. So you'll have a few less type to do in tonight's work. Here's some practice for you before you actually go into the work. Look at AB and CD, find the slope of each one. So the slope of AB and the slope of CD, and compare them. If they're the same, they're parallel. If they're negative reciprocals, which means their product is negative 1, they'll be perpendicular. And if neither of those situations occur, they're neither parallel or perpendicular. They're just two lines that intersect. A reminder again, on Wednesday you have our test over this unit. Tomorrow in class we will do our review. And then on Thursday we have the Unit 1 retest. If you wish to take that, which a lot of you should, on Math Excel, there is a Unit 1 review for retest that you need to complete in order to be able to take the retest. If you do not complete it, you cannot take the retest. So I'll be looking on Math Excel to check to see if you have completed it. Again, it's practice problems of that particular type that was on Unit 1. I'll also post something into Schoology that explains each of the 7 problems that you can find on Edulastic. I'll see you tomorrow in class. Make sure you get this done.